All right. Thanks, Patrick, for mentioning me in that loop of somehow a way of AI to Lean shipping and to LINHAC. And that picture also remind me two things. So the first thing is last time I gave a presentation in this room was actually my PhD defense. And Marco is also one of my committee members. And the second reminder is that picture showing the relationship between supervisors and PhD students is kind of a way of knowledge representation for ontology. So each person is each supervisor and each student is a particular instance for some concepts like supervisors or PhD students. And we have the relationship like supervision relationship. So that comes to my talk for today, which is ontology for ice hockey. So before introducing details of this ice hockey ontology, I want to introduce some overview, background, and motivation. So one thing is very common in many different domains, like Patrick mentioned, is we usually have different data providers. And sometimes they provide data in different ways, like maybe using different APIs. And in many cases, the data from different data providers, they follow different data models. So taking ice hockey as a example domain, we may have a scenario like we want to compare players' performance metrics in last several games. So for example, as a fan of ice hockey, I may ask a question like, give me the two players' performance metrics in the last 5 games. And I'm interested in two players, one from SHL, from LOC, and another one from AHL. So basically, I go to these two websites, one from SHL and one from AHL. So let's see, here is the result. At the top, it's the result from SHL, and here is the result from HL. So after the first look, I found that there were different amount of information returned by SHL and HL from those two websites. For example, in SHL data, we have actually 15 columns. And for the data from HL, it has 12 columns. And another difference is the language differences. For example, we have different words for Swedish and English. Then when we keep looking at the detailed information, we find more differences. For example, some information, some same or similar information, they are represented in different formats. For example, the actual date of a match, which is quite represented differently in this data table and this data table. Also, the information about home team and away team, they are represented differently. And in addition, from here we can see in the SHL data, it shows if a match is from a playoff series or regular season. But for this data table, it doesn't show, but I'm sure the information is stored backend. It's just not shown in the front end. Then we also see some other metrics. They are represented differently at the schema level. For example, from the SHL data, we have the TP to represent total points. But in the NHL data, we just have P to represent points. But I think they represent the same thing, which is the total points a player scores. So life is not always difficult. We have something in common, which is some common statistics like goals, assists, plus and minus, power played goals, short-handed goals, as well as time on ice. So I just show a very simple example. But when we move on to, for example, representing play-by-play data or use play-by-play data from multiple different sources, we face the same problem. For example, in this slide, I have two examples, which is the play-by-play data from two data providers. For example, they represent event with different name. Here we have event. Here we have event name at the schema level. And for a specific face-off event, here we have a capitalized face-off, and here we have just a lowercase face-off. So of course, these kind of differences, they are easy for our human or domain experts to understand and distinguish, but sometimes it may be not easy for computer programs to distinguish if we don't encode our background knowledge or domain knowledge to the computer programs. And learned from Patrick, and in S-Hockey, yet another scenario is we have these new performance metrics. They may be modeled based on different calculations. For example, the expected goals. When calculating such performance metric, different models may take different contextual information into account in their computations. So all these issues actually they are not they are not only exist in S-Hockey domain, but they are challenges in many other domains like materials design domain, which is the research topic in my PhD work, and also, for example, in badminton domain. And I'm a fan of badminton, so I looked into badminton domain also. And based on the talks we had in previous 2 days, I think we also see the interest that at some point we may need integrate multiple performance data and play-by-play data, as well as maybe cognitive data at some point. So definitely we need some common model as well as standardized data model that can map all these single data models. And we need a semantics aware way to integrate data or combine data from different data sources. So these are our previous works. We focus on addressing data integration challenge in different domains, like in S-Hockey, material design, and badminton. So now we can introduce some detail about ontology. So what is an ontology? A very early definition is ontologies define the basic terms and relations comprising the vocabulary of a topic array, as well as the rules for combining terms and relations. So here I show an example for S-Hockey. For example, the topic arrow is we want to model data for representing S-Hockey team. And we may have the terms like coach, team, player, S-Hockey team. Then we can build an ontology to represent such domain. For example, we have the general concepts, which we use the terms to define the concepts, for example, team and coach. Then we define the relationship that a team can have a coach. In addition, we can also define sub-concepts. For example, we can define a S-Hockey team is a sub-concept of team. Then at the same time, we can define some data instance. For example, Alosia is a specific S-Hockey team. And also in ontology, we can define some rules. For example, we can define a S-Hockey team must have a certain number of S-Hockey players. Then in the ontology, we can also represent some facts. For example, Alosia is a S-Hockey team. Klaus Ostman is the head coach of Alosia. So We can use ontologies, for example, as a communication between people and organizations. It can be also used as a way to do knowledge reuse and sharing. As I show, we actually model the domain knowledge, so it's also kind of a repository of information, and it can be used as a query model for information and data. And for our work to build a ice hockey ontology, we actually focus on representing gameplay data in ice hockey games. So this small ontology is not enough. We need more terms to describe the domain. For example, we need the terms like events, shots to capture the meanings in, to capture the semantics that we need to use to represent play-by-play data. So this is a joint work with Robin, Dean, Nicholas, and Patrick. We build a small ice hockey ontology, and we want to annotate play-by-play data. For example, we specify some different concepts, like different level of events. For example, we may need some shot event to represent an actual shot in the game. And we may have some event like face-off event, hate event. And in this ontology, we also want to capture the game status, like the home team score, away team score, as well as the information about players on roster. So by having such an ontology, we can answer, we want the ontology to help us answer questions like, give me play sequences preceding goals. So now I want to show how we can use ontologies in data integration. So as I mentioned before, we face the issue like many different data sources, they provide data in different ways. For example, we may have different data sources. For some data sources, they have APIs. For some other sources, maybe we need our own scripts. And imagine we want to ask some query like, we want to query data like to integrate performance, medical, as well as cognitive. We can use the ontology as a global schema. So we can implement a program, and we call it mediator. So this program communicate with all the underlying data sources and combine the data according to the ontologies. To summarize, in our group, we work on knowledge representation to address data integration challenges in many different domains, because we see that in many domains, there is the lack of standardized models to annotate or interpret data. And by having ontologies, we can enable better communication among people and organizations, because ontologies can provide a standardized way to model data. And once we have well-defined ontologies, we can enable some ontology-based data integration applications. So we also have some other technologies in the semantic web stack. Yeah, that's all my presentation.
More questions? I have a question for the data providers then. How much do you guys work on standardization of different terms? Andreas, Albin, Jon, who else do we have? Is there any work that where you're sitting together to try to define exactly what is going on, what the actual things mean in your data sources?
Yeah, maybe I can I can just, I mean, it's a very basic level. Like we, as data provider in Switzerland, we sit together with them and have clear definitions on what's a shot on goal and so forth. But nothing like here that would obviously make it easier to at a deeper level and leave alone then agreeing on certain standard models for XG or something like that.
No other questions? Niklas?
So I guess a follow-up question. So would you have any tools that would help them, like ontology mapping, etc., to help providers map between each other?
There are tools like we can define mappings like between different, for example, how to map the data sources schemas to the central ontologies. But we need ontology first.
So in his PhD, he actually worked with a large consortium of data providers in the materials science field that store huge amounts of high performance computational data. And so there, what he has done is he's created a system where he created an ontology. We create mappings between the data sources and the ontology. And then he has a system that generates automatically a query system that integrates all these data sources. So people could ask queries to the actual system that he generates, and it takes care of the integration of the underlying data sources.
In that process, have you gotten then the large companies to agree on your ontologies, that they can agree that a hockey puck is a hockey puck, or a definition of something is the same, or is it different from different companies?
For this as hockey ontology, we haven't have any talks with companies, but in general, that's a process we need to discuss with experts of these data providers.
I didn't expect you to have done hockey, but with what you did your research on, that was in big companies, and they could agree on ontologies. That's the whole point.
Yeah.
So it can be done. That's my point.
So it started 25 years ago in the field of biomedical informatics, and specifically the pharmaceutical companies. They understood that there is common data online that is interesting for everyone. And then, of course, they have their own business data that they don't want to share. But there is a lot of gain that can be obtained by actually on the pre-competitive level work together. So they have both in the US and the European Union have put quite large amounts of money in building these kinds of ontologies and building these kinds of systems so that all these pharmaceutical companies can start a much higher level with the competition. And now, since 5 years, the material science field is also coming in up there. But lots of work in biomedical fields.
Yeah, maybe to this point, there is a lot of exchange among data providers. So but typically how it works is we exchange a data set or so, and then it's kind of, we have a couple of meetings to try to understand the denominations and map them and everything. And then what happens is obviously you're not able to appreciate the full depth of the data set because maybe you don't have them likewise. And then some companies have data with more expertise in the data, in the single data point, and maybe we try to be more atomic in the single data points and so forth. But I think for a conference like this, and with all the analysts basically saying that there would be tremendous value in the standardization and easy access of data, I think that's certainly a discourse to have and to reach out to all the different data providers. And you always have a pretty big subset that are similar or alike with some smaller differences in naming and so forth. But certainly something I think that would be sensible to look at.
Okay, thanks, Huanyu.